Monday, everybody. Let's see what we got here. How you doing, Ice Top? Congratulations on being number one. Yes, I just saw your message. Let's log right on in to AWS real quick. Everything in that bucket should be publicly available, but obviously it's not. So let's log in and let's take care of it really quick. But how is everyone doing today? Happy Monday. Welcome back to Mastermind Academy. Welcome to Hoist, infrastructure provisioning with Terraform. You have made it to the final week 3 of 3, episode 5 of 6. Tonight's gonna be a good one. Tonight we're gonna be learning a little bit about I think we're learning about secrets management tonight. Secrets management. We'll also be learning about functions and kind of dynamic templating, and we'll also be doing, there's one more thing. I could look at it, but I'm trying to remember what's on the calendar. The last thing is importing existing infrastructure. So we'll get to do all of that dope stuff tonight. And let's see what's going on with this 30401 in our solid 10 minutes before we kind of get started. What's up, Daho Ramos? Welcome tonight. Happy Monday. I have no idea what bucket I put this in. Do you have that link handy? I think I put it in, I have no idea where I put it. I'm trying to think. Did I put it in the academy.mastermind.io bucket? Is it here? It is not. Let's see, let me check my history. Let's see, export mastermind. Actually, let's just do a history. Let's also grep AWS S3. Let's see all of our, whoa, grep. Oh, that was dumb. There we go. Okay, we put it in. Nope, don't have it at all. This is all old stuff. Yeah, Isotop, do you have the link for, which bucket we put it in? If I also do it live, no. Or do you have the link that I gave you last time? I don't remember where I put it. I don't want to upload it again. But okay, it is an academy.mastermind. That's the link that I sent? That's, hold on. Did I stick it somewhere? I don't think this is where I put it. And maybe that's the problem. Maybe I put it in boot camp. Try www. All right, in one of these buckets, there is, I can search by size. Or maybe I'll have to recopy it. I know I started copying it and it took a long time because it was a large file. But wait, let me look at it one more time. I didn't put it in the root, obviously. It's not in the root, and did I accidentally put it? Yeah, I guess it's not here. I must have put it in the wrong bucket. I don't feel like looking through all my buckets. I apologize. Wait. We're gonna just click one to test. Where else might I have put it? If I didn't put it in Academy, maybe I put it in Boot Camp. No, it's not there either. Okay. All right. This is good. This is bothering me. Wait. Maybe I didn't do it from the CLI. That makes it even worse. That's why you should do everything from the CLI, so that you can have a history of all the things that you did previously. But I will make sure that happens. I'm sorry. Okay. I don't know what happened. But what we're gonna be doing tonight, let's let me give you the link to this. Here is the link to tonight's slides if you need it. Yeah, we're just gonna go over a couple of things. Shouldn't be too crazy. We'll be pretty hands-on tonight. I was running through some of this stuff. I was getting ready for the lab that's kind of on Wednesday, and I was working through the lab to make sure that we can get it done in a reasonable amount of time. I would ask that everyone hopefully be willing to stick around for 2.5 hours if you want to finish the whole thing. Obviously you can leave whenever you want, but 2 hours for that one is a little, like, because we're gonna be so hands-on, we're gonna be waiting for things to provision, we're gonna be waiting for things to get done, and we're probably gonna need an extra half an hour or so to kind of get through everything and to, you know, confidently go into all the things that we're doing. So yeah, YouTube, just want to let you know the link in your Twitch and your YouTube descriptions is broken. That's not good at all. So you can see here, I'm struggling with some of these things. First off, thank you very much, A-Trax. Good to have you. Welcome to the channel. Let's check out some of these things. Let's see. My link to Twitch is... yes, there is in fact a dot in there. I will change all these today. Also, I don't know what happened. It used to accept, YouTube used to accept Markdown. And this obviously is not Markdown. Well, it is Markdown, but it is not rendered Markdown. Aha, yes, Mr. Primigan. Welcome to the channel. First off, shout out. First off, I just want to let you know that people over here have taught me tons of Vim stuff, and now, you know, I might be the Vim champion now, just so you know, just so you're completely aware. Yeah, it did. It used to accept Markdown right there, but we'll see. Well, let me see, shout out. I mean, I still can't type that well, so that's where you still have your powers are over mine. But yeah, but we're there. We're you know, we're there. I'm getting there. But yes. Okay, I will. I'm adding that to my list of to-dos. You know what? Let me just grab my Notion really quick. I have a bunch of stuff to do. Actually, let me move this over. I will add that. I need to fix my YouTube links. I appreciate that. I actually have a whole YouTube overhaul coming because, you know, everyone, you got to do YouTube, and you know, I prefer Twitch. I thought I was gonna really like YouTube more, but to someone who's, you know, just a little bit lazy, I don't have to pre-think of anything, and I don't have to edit any videos, which is really nice. It is really nice. But like I said, tonight we are going to be knocking out kind of the final topics of Hoist. And so what we're going to be doing tonight is covering kind of those last few things. Now, there's a lot that kind of falls into some of these categories, especially the functions category. There are a lot of internal functions, intrinsic functions that Terraform has, but it's not important that you know all of them. You just need to know that they're there so that you can get great at them. So let's get started, because I think tonight's going to take us a little bit of time. So Hoist, infrastructure provisioning with Terraform, day 5 out of 6. Let's do it. Today's topics: secrets management. Definitely secrets management is pretty important here. Not too complicated of a thing. It is complicated when you put some of it into practice, or can be, at least the setup of some of it. But we're gonna learn about secrets management and what you can do there. We'll learn about the functions that Terraform has internal to it. So Terraform is not using a dynamic language like you're probably used to, something like Python. It uses HashiCorp configuration language, its own domain specific language, and so it does have these things, and so we'll learn how to use some of those things. And then we'll learn about importing infrastructure. This is a big one. When I first started using Terraform, I did not know this was a thing. I'll be up front with you, this sounds better than it is. It is not that amazing, but it is useful for sure. Will the Waddle videos be uploaded to YouTube? Waddle should be there. Waddle should be there. Let's check it out real quick. Let's just make sure, because you guys know I've been super busy the past couple weeks trying to get all my stuff together. Oh, Primigan, Mr. the Primigan. I don't know if you knew, but I'm going full time. I'm going to be a full time entrepreneur in my own business starting September 19th. September 18th is my last day. You know, I have to make one of those, you know, de facto, you know, why I quit my software engineering job videos. But yeah, I'm leaving the corporate world for full time entrepreneurship, and so that's what I've been super busy doing. So if I'm missing any videos, then I will have to get those up. Decoded. I think you are right, but no problem. That's not a problem. I have everything recorded, so I will get those Waddle things up as well. So I'll put that on my list as well as things to upload. I will get those up Man, I didn't know I was that far behind on stuff, to be honest. Like I said, my focus has been a little bit shifted, but I promise you, just give me a couple of weeks. Just give me until mid-September, and we will be back. We'll be back, you know, super focused on these things, but I'll get Waddle up. I'll try to upload them tonight. I think they're already rendered out. I do have to render out the videos, which really sucks. To remove certain things, but I will, I'll try to get that up today. Is the business a mentoring business? It is. It is not. I can't. So many people have asked me that. Well, okay, so that's not true. It's not a mentoring business. The sole focus of it is not specifically mentoring. Part of the business will be to help guide engineers' paths and help connect engineers with companies. And also to help companies understand their engineering journey as well. So yes, in that sense, there will be, but there's not going to be any, hey, you pay me to come get mentored. Not at all. It'll be on a little bit larger scale than that. But again, all the information will come out about it. I'll give you guys all the information about what Mastermind is and all the things that we're gonna be doing. But we'll still be doing this, and we'll be doing more of this. That's what's gonna be exciting. We'll get to do a lot more of this. That's why we're not doing any of the journeys right now. We're just trying to hold out until that September 19th date, when we have all the time in the world for us to do some real journeys and to get real good. A lot of changes coming along. What's up, Aya? How you doing? What's up, Mulatto Express? How you doing tonight? Twitch VODs automatically get deleted after 2 weeks. To save them forever, you can highlight the whole VOD. Oh, okay. I did not know that. Well, I knew that they got deleted. I did not know that you could save them. So I will maybe start doing that. Does that make it difficult for people to find the most recent stuff? I wonder how that like muddies up the page, but I'll definitely try that out. But I record them all. I have them all saved at the same time I'm streaming them. I record them so that I don't lose them as well. So Richard, drop by to say hello, Richard. How are you doing today? Hope everyone's doing well during lockdown. Yep, doing good, as well as we can be doing. First off, I don't know if any of you, I haven't been posting on my Mastermind social media, but on my personal social media, which is also like kind of my Mastermind social media as well, your boy is getting big into cycling now. You know, I've been doing more and more miles. I was trying to do 500 miles in the month of August. The only thing that's really stopping me right now is the rain, for one, which, you know, I could still get out there if I wanted to, but I tweaked my hamstring earlier, like last week a little bit, so I slowed it down a little bit. But I've been, you know, my rides have been increasing. You know, I'm up in the 40-mile range now per ride. So, you know, I rode about 80 miles this week, 40-mile rides, but I got some nice clip-in shoes. I'm on the clipless train now, so, you know, put your feet in the bike. You know, I'm connected. Me and the bike are now one. And I'm probably gonna do my first 50-mile ride or so this weekend, but weather permitting, you know, I'm going to announce it here now so that, you know, there's some accountability. But weather permitting, what I want to do is my last day in the corporate world is Friday, September 18th, Saturday, September 19th. I really want to do a century ride. So I really want to do a 100-mile ride. Not super fast. I'm not a racer, but I'm probably going to record it. I'm gonna, you know, it's going to be my rite of passage as I transition over into my own company. I'm going to try to knock out a century ride, 100 miles. Probably take, I'm hoping to get it done within 6 hours, but I'm going to like stop and eat and stuff. I'm not going to kill myself, but I'm going to finish it for sure. So, you know, just keep an eye on that. I'll probably be posting some fun stuff on my way there, like as I'm kind of training and, you know, getting my endurance up and getting ready for that. But cool. What's up, Uncle Bill? How you doing? What's up, T13? How are you doing? What's up, virtual assistant? Maybe I'll live stream. Maybe I will. Maybe that's pretty interesting. I might try it out. Yes, my own company. Absolutely. It all started, you know, this is actually a, you know, an interesting part of it, and I'll give all the information in the story on how the company came to be, kind of things I've been working on over the past year and a half, because I have in fact been working on a ton behind the scenes. And again, that's just why I've been so busy and I forget to do things like upload some of the videos. That will change very, very, very soon. That will be much more important to me, and I'll actually have the time to do it. So let's do it. Let's get started and start talking about YouTube. This is AWS, we don't really need it. This is Giphy. We don't need Giphy either. And we need some Terraform stuff. All right, well, let's just pull up the slides again because I don't know what I just did with them. Must have deleted them. Let's hop straight in to secrets management. And let's talk about it, because secrets management is pretty important and it's a big piece of a lot of tech, especially nowadays. You know, managing secrets is really important. So first, oh no, stream keeps dropping. For anyone else, let me monitor it. I don't see, none of my metrics say it is, but every time y'all tell me, it is dropping whenever you tell me. So let me check over here. Let me view it as if I am a viewer. A little bit of stream inception over here. All right, looking pretty good on my end. I'll keep an eye on it. I sent a messenger. His backpack has LTE built up. Hey, you know, sometimes that's, you know, you got to do what you got to do. That sounds pretty cool, actually. LTE in your backpack is pretty sweet. But what are secrets? Secrets are any sensitive data that Terraform needs to access in order to deploy and configure infrastructure properly. Now, secrets are not unique to Terraform, but again, we are talking about Terraform, and we want to phrase this as if we, you know, in the realm of what we're talking about. But it's all of the sensitive data that Terraform needs in order to deploy and configure infrastructure properly. These include things such as usernames, passwords, and API keys. So very, very important. This has become something that's been very important in the world of infrastructure as code. So what we are learning to write is infrastructure as code, and these things are very important. So when you're talking about codifying infrastructure, you're talking about putting everything into code. How do you handle things like passwords? You've learned from day one, you know, as soon as you started using a computer, people said, hey, don't write your password down. Someone will find it and steal it and hack all your stuff and steal your identity, and you will be, you know, you'll be homeless. That's the flow that it takes when you write your password down. And so we need to learn how to manage these things so that when we're writing our code, our passwords and our sensitive information isn't there for everyone to grab. So secret no-nos. So there's a lot of different ways to manage secrets, and we're going to learn about the high level concepts of managing secrets. We're actually we're gonna learn about the higher level concepts of managing secrets, but there are some no-nos here. So since it's important that no one can find out our secrets, there are a few things we should keep in mind to keep ourselves safe. And again, this is important in terms of Terraform. I was gonna make this a more standard secrets management thing, which can get pretty big actually. Secrets management, like I said, is a really big thing, but we're just talking about Terraform tonight. But these concepts do apply elsewhere. Do not store secrets in version control. So every night, what we've been doing is we've been doing some Terraform, we've been writing some Terraform code, we've been committing it using Git, and so we can track our progress, and we've been pushing that into GitHub. And although we don't have any passwords in there, if there were passwords in there, we want to make sure that there aren't. We're doing the right thing right now, even though we're not utilizing any passwords yet. But do not store secrets in version control, or anywhere for that matter, in plain text. And that in plain text is key. It is very key. So we'll learn a little bit later on how you can still store it in version control, but plain text you cannot. No, am I dropping? I look good over here on my end. Sorry, I think Twitch must be having a day. I'm looking good. Stone Cold Stream Austin is able to view Mastermind pretty clearly right now and right on time. So hopefully we're all good. But unless you were talking about F for storing passwords, when you let your passwords just go in plain text. But yeah, so plain text is key. And plain text is simply the text that you type into your computer. You do not want to store any passwords inside of version control that way. So you don't want these passwords in plain text in your code. And then the second part here, there are other secrets that we're talking about. Normally we're not talking about state, we're talking about secrets, but your Terraform state, I want you to treat it as a secret. I want you to think about it as a secret. It is that important. So I want you to treat it as if it is something that you don't want anyone else to get, have access to. You don't want it to be compromised. And so keep your Terraform state safe. And so we've talked about last time a couple of different ways to manage state and where to put it, and what you can do with it. But tonight we'll expand on that a little bit. But these are just two big things that I kind of want to talk about tonight. All right, let's move on. Secret management options. How about security by obscurity? Yes, so that is something we're going to talk about. That's what we're going to talk about in a little bit. Actually, right now, you'll probably see a little bit of obscurity there in the encrypted file section, but you have kind of three main methods for handling secrets in Terraform, and they all have their pros and cons, and we can talk about some of those, but these are basically the three ways that you're generally going to want to handle them. Environment variables. So we talked about this already with the variable section. Remember those TF_var_ variables. These are ways you can manage some of your secrets, and so this means you're going to be doing this on a system level, and so you can set these, and these will not you won't have to check these things into your code. They can be read from the machines that you're going to be pushing to. It's, you know, this is a great method depending on what you're doing, but just you know, some of the things that are great about it is kind of ease of use. Environment variables are something that are pretty common and easy to set. You don't need any outside tools to configure environment variables usually, but now you're managing these passwords, you're managing these secrets outside of your infrastructure as code. So you know, you now have a whole separate way of managing this thing, which, you know, can cause some issues with consistency, with, you know, someone's got to manually remember to set these things up, or you got to have another process to handle these things. And so it moves it out of Terraform's hands, which again, might be good for you, may not be good for you. If you're using another tool that allows you to do this easily, maybe you want to combine these things to make it easy. But that's one of the biggest drawbacks, is simply that now these things are not managed by Terraform, and that creates that can create some confusion when someone is trying to understand what the code is doing. But yeah, there's one very simple way that you can do it. Remember, we also talked about that hierarchy and the way that Terraform will read in those variables. So keep that in mind when you are using these environment variables to manage these. So what's also good about these is, as Terraform is, as it's logging, as it's outputting information, if you are configured to use variables and you're having it pull from these environment variables, it will not spit out your passwords and your secrets in those logs, in that output, because it will spit out the names of the variables instead. Correct. A state should be untracked. As far as source control goes, it should be untracked. HashiCorp Vault. Yep, we're gonna talk about HashiCorp Vault when we get right here. We're not gonna do anything with it, but we are gonna cover it a little bit tonight. What's up, Sally? How you doing? All right, so the next thing we have is encrypted files, and so this one is a little bit different. So for environment variables, everything would exist as you're currently used to. You would just have to set up those environment variables. So environment variables on the system will look something like this. I would say, hey, I want to set up an environment variable for, you know, the base URL. Maybe we're deploying a site and it needs to configure base URLs, and I might say something like export. It needs to be, I always forget what they need to be. TF_var base URL. And so then equals, let's say, you know, www.mastermind.io. Maybe I'm deploying an app and I want this variable to be set up. I can do something like this, so that if I echo out $TF_var_base, it spits out the value, so I can use this as a placeholder for that value. but you can have these things set and you can get them moving, and they'll be set on the system. They're set on the environment. This can be both, if you don't fully understand environment variables and you don't understand how like shell sessions work and stuff, this can be very confusing sometimes, especially when you're trying to troubleshoot. It can be pretty confusing, trying to figure out what's going on. But again, it's something that is outside of Terraform. It is on the system itself. So make sure the system that is running your Terraform, that's executing your Terraform code, is where you're going to set that stuff up at. But these encrypted files, on the other hand, will be text files that do have the secrets information that you want in them. But they are encrypted. This is that security by obscurity. This is taking plain text. So what you do is you create a file with the secrets that you want inside of it, and then you encrypt those files. And the thing that you can push to source control is the encrypted file. If you can push the encrypted file if you like, up with your stuff, because ideally, if no one else has the keys, they cannot decrypt the things that you encrypted. So this can be interesting in a couple ways. It has a little bit of a similar problem as the environment variables. It things like secrets rotation and stuff is not handled. You've got to manually do a lot to manage those secrets, but it's pretty easy to set up. It's pretty simple to do. You just kind of gotta, once you have the key, you simply have to provide it to Terraform so that Terraform knows how to decrypt these things. It's actually a pretty simple process, and we'll look at an example of a resource that does this, but we're not going to do anything with it right now. We might do something with it on Wednesday. But yeah, so create a file with the secrets that you want in it, and then you encrypt that file. Also, you got to worry about the management of that key. If that key were to get compromised, you've got to worry about swapping out those keys and re-encrypting and understanding how to handle that. But it is it's a little bit better of an option, I think, because it's a better option, but I use it less than I use environment variables. But again, it allows you to now manage your secrets within Terraform, so you can keep your secrets inside of Terraform, and they're encrypted. So it's kind of nice. It's kind of good. You just got to make sure that key stays active and managing that key. And so there's a couple of different encryption types that you can use: KMS, PGP. There are a few others that you can use, whichever one floats your boat. Since we're doing AWS, a lot of people opt for KMS because AWS has its own pretty simple KMS encryption service. And it's pretty easy to use. But yeah. And the last thing we have here, these are the go-to solutions for enterprises, and a lot of solutions would be these secret managers. These are tools that are designed specifically for the usage and the management of secrets. These are tools that were created for the problem that infrastructure as code causes. It basically is a place for you to input your secrets, to rotate automatic secrets rotation. So maybe it'll rotate out secrets every 30 days or whatever you decide. It allows you to kind of set up who and what has access to these secrets as well, and it's really nice. Now the two secrets managers we have here, the first one is Vault. Let's see, which is a HashiCorp product, HashiCorp Vault. And again, you can use it for a lot of stuff. So it allows you to easily store these things, and it provides a bunch of tools. Now, let me be clear that Vault and AWS Secrets Manager and Parameter Store, those are two other things that we just talked about that are a part of this section. They're going to be overkill for probably going to be overkill for some of the things that you just want to do personally or for smaller projects. These again are generally better for bigger solutions. The overhead sometimes of setting these things up can be annoying. Now, the cloud resources that they have may work well, may make it easy, but they cost some money. I actually think Vault is fairly expensive. I think AWS Secrets Manager is not super cheap either. especially when Parameter Store I think provides the same level of security. But Vault is, again, it's pretty cool, and a lot of tools like this is not a tool that only Terraform can use. A lot of tools can use this. A lot of different things can pull secrets from here. You can create any kind of application or tool to pull secrets from here and be able to use them properly. But use your key to encrypt stuff. Okay, KMS has a size limit, but if you request a private key token, yeah, that's true. We're all on AWS, Secrets Manager, everything rotates now. Yeah, I guess that's the big thing that you get from it is the secrets rotation. But I don't know, man, for a lot of things, like, so everyone was using Parameter Store first. And then they were like, it felt like they just released Secrets Manager at first. It didn't have a ton of benefits, but it had the word secret in it and people will switch to it. At the time, we could not find many tangible security benefits to using it, but we have since used it. We use it for newer applications and certain things. It sucks a little bit because the retrieval of data is actually a little bit harder than it is for Parameter Store for a lot of AWS's built-in things, especially in like CloudFormation. But well, I guess CloudFormation it can be just as easy, but it's a little bit weird. Yep, yeah, it's the same thing. I'm using Azure now. Directory Hacking Lab. Oh yeah, I don't mind Azure at all, not even a little bit. I think Azure, like I said, from what I've done with it, it's pretty cool. You know, it works well. Just generally because I already know AWS so well, then I kind of just stick with AWS. But I fully plan on doing some stuff with Azure on here. Full confirmation, create, delete from DB functionality. That's dope. That is pretty cool. Okay, so yeah, there's a couple of tools. AWS Secrets Manager. Let's see, console. Are we already logged in? And again, the thing that these tools give you is they give you some good management of because they manage the secrets in the way that they do. One, they give you an external place to a point of contact for these secrets, which is nice. The reason why that's nice is mostly because we live in a world of where scalability is king. And we have things provisioning all the time. You never know the number, you never know any of that. So it can allow things to pull these secrets at runtime. So you don't have to actually inject the secrets into the actual item. You don't have to put them into the Docker container or anything like that. You can actually pull them at runtime if you need to, which is kind of nice for a number of reasons. It also makes it so that if a secret should change, you don't have to redeploy everything. You just have to cycle out things, which is nice as well. But cool. Let me check your Twitter DMs tonight. Yeah, I'll check it out. I will check it out. I want all Google products. All of them. I mean, you know, Google does some cool things. Definitely does some cool things. Okay, so yes, that's secrets management. And again, tonight we'll do some stuff with environment variables, but we're not going to dive too deep into any of the other things. And maybe actually let's take a look at our code that we've developed so far. What are we in? Hoist, and we're in Hoist Terraform. And inside of Hoist Terraform, again, there are different variables that exist in here. So for things like the developer instances that we have here, we have this variables.tf file. And in this file are different variables that we can define. Well, we've already defined here, but we can assign values to and kind of set things up. But see how we have these defaults here for different items. Right now, actually, I don't even know if this is deployed. Let's see. Terraform state list. Okay, so we tore all this down. So let's actually do a let's actually look at this file really quick. one way, let's say we didn't want anyone to know what our SSH key name was. Again, not super important, but imagine if this was an actual password or hash or something like that. We would simply be able to, again, define an environment variable with the tf_var_SSH key item if we wanted to. But again, then we need to set up some type of management or something so that these environment variables could get set up. So we didn't talk about workspaces yet. We are actually going to talk about workspaces first thing next time, even though next time is the lab. Workspaces are important, but workspaces kind of allow you to kind of set up these variables need be depending on what workspace you're in. This is really important when you're working in different types of environments and things, and it can work out pretty well. But we can simply set, let's say, no, we're gonna leave it as Hoist, but maybe the default was not Hoist. Yeah, maybe it was not Hoist, which is the wrong key. We could definitely set up an environment variable, tf var underscore, and that was SSH underscore key, I believe was the name, equals Hoist. All right, so now if we were going to do a Terraform apply, AWS version installed, provider, oh really? Very interesting. I'm not sure we had to reinitialize, but not a problem. So we don't have a bunch of stuff set up, but let's enter this stuff in and let's see if it asks us for the key. And here is the key name, because we defined it as Hoist as an environment variable, it says Hoist. It is actually set up as not Hoist in the thing, but again, it overrides here. And again, we can do that with these, simply with these environment variables. And again, that's really nice. If you were to use something like, like Vault or the KMS encryption or something, what it would do is it would, if this was the encrypted files, it would then take on, it would say, hey, you can set up this this kind of data block and you can specify the key, and it will use that. It'll say, hey, I understand that I have a file in here that I need to encrypt or need to decrypt. I need to decode this file before I do anything. And when you do an apply, it'll go through and it'll make sure it decodes that information, and then it applies that information to the run so they can gather the information that it wants. And let me show you a little example block of that. Terraform. No, I don't want to. You can set up these data sources, but let me see. KMS, decrypt. But here we go. So you can do things like this as well. I've never used it like this, but you can also set up these you can set up these data resources. You can actually set up data resources, and so you have a secret here, and so you can give it a name, something like master password, and then you can give the encrypted value of this. So this is not the actual plain text password. This is an encrypted value for it, and you can have it basically at runtime decrypt these things and make sure that it gets imported properly. And so again, it's nice. It helps a lot. There's a couple different ways to kind of handle this. You can do it with entire files as well. Yeah, you can use your KMS key to encrypt it if you want. It's a pretty simple thing. Like I said, pretty simple to set up. It's probably the easiest to set up. It's probably the easiest to set up, like when you're not thinking about the entire pipeline. The environment variables are probably the easiest to do, period, because environment variables you can just set. But again, you got to think about the pipeline. This is not something that you can handle inside of Terraform. You can now not codify those things. And then, like I said, Vault or those secrets managers. Vault or secrets manager is the hardest to set up, probably cost the most as well, but are kind of give you the most functionality for your secrets as well. So got to just kind of weigh your options there. All right, so now that we've talked a little bit about secrets, we don't need to spend a lot of time worrying about secrets. We will manage secrets tonight and tomorrow, but we don't need to spend too much time on that. Just understand, don't put your passwords in there as plain text. That's really what I want you to know. Don't put your API keys in there as plain text. You do have options for it, and you can fit, you can work through some of those options. All right, now this is the more fun part of Terraform. This is where a lot of the cool stuff happens, and this is where a lot of people don't know. I know a lot of people who've used Terraform for a while and don't know a lot of these things exist. You may not need to use these, but they do help. Again, make your templates much more dynamic, and give you a lot more flexibility in the things that you're doing. So we talked about HCL and HashiCorp configuration language, and that it's a way for you to configure the infrastructure that you want to build. It's a way for you to codify it. This is not a normal programming language that you're used to, but it does provide you a lot of that functionality, or provide you a lot of functionality that exists in those languages that you are so fond and familiar with. So all that programming goodness, just like any traditional dynamic language, such as Python, HCL provides you tools to do some pretty cool things. And one of them is loops. One of the coolest things is loops. And so let's take a look at loops really quick, and we'll do a little loop. And so you've already seen an instance of loops. Now, for anyone who's not familiar with loops, loops are a tool in programming that allow you to execute some code multiple times, so that you don't have to keep rewriting it. It allows you to define a situation and run this code as long as this situation is happening or is true. And so Terraform allows us to do many of the same things. Because it is written in Go, the only type of loop that you really have are for loops. So there are a couple different ways to work with for loops in Terraform. That's not what I wanted to go to. I wanted to go to the actual Terraform preview. Interesting. Excuse me. But yes, take a look at down here. This looks like Python code. It says for num in var.subnet do something else. So there's these for loops that we're going to be using. You've already seen an example of a loop with count. You've seen us use this count command, or this count option here, and I think it exists right here in the dev instances.tf. There is this count resource, and count is just is a parameter that's a wrapper for a for loop as well. And so it's pretty interesting. And so whenever you do a count, it iterates over the sequence of items in that array, and it does actually create an array for you. An array is just a collection of items. And so it says, hey, if you want 3 servers, I'm gonna, create 0, 1, and 2, and I'm gonna give them these names, and I'm gonna iterate over them to create them. A way to see that count might work a little bit better is you can do some cool stuff with count, but maybe not. Let's do a for loop let's combine it with maybe a list of items. A lot of times when you're looping through things, you might be iterating over a list. So maybe you have a list of shopping items. Maybe you need to go to the store. Maybe you have a shopping list of things that you need, and maybe you need to go through that list one by one to either find out what information is there or make some changes to each of the items in the list. And what you would do is you would iterate through all of those things and apply whatever bit of code that you wanted to apply to them. we can do the same thing here. So let's say that maybe maybe we had something like this instead of let's open up, that's not what I meant to open up. I meant to open up variables.tf, and maybe for server I could do something with the count here if I wanted to, but maybe instead of using a count, we'll do something like server names. And what we can do is we can set up, remember there are other types than just numbers and strings. We focused on just numbers and strings for many of the things that we've done so far, but there are also many other options here. So Terraform, variable types. Remember that the types in variable are, this is a strongly typed configuration language. The types do matter, but you have other things like this. And this says list of strings. So right now we've been utilizing strings, which is an individual, word, collection of letters, but we can also do something like this, which is again a list of strings. And that means instead of taking in one single string, we can take in multiple things. So maybe we had a list of server names. So whenever we use that count before, if we were trying to spin up 3 web servers, it would name them basically inside of Terraform. It would give them the same exact name inside of AWS, which may be problematic. For EC2 instances, it's not a problem, but because the name is not a unique identifier and doesn't actually have to have a name, but you may need to, it would give the identifier inside of Terraform as web server brackets with a 0 inside, and then web server brackets with a 1 inside, and then one with a 2 inside, which is, it works, but it's not very descriptive. And again, it might not work for a resource that needs some type of unique name to be provided when you are deploying things. And so what a collection looks like is an array, and so I could have a couple of strings. So I could call this maybe like web server alpha. Maybe I always want a development web server called web server alpha, and maybe I want a web server beta, and maybe I want a web server Charlie. I think that's the ABCs of the military. But so now instead of having a variable that equals a singular value, I now have a variable that equals a collection of values. So this is the default things that can be passed in, and so we can utilize this. And you might say, all right, well then, if I was going to do this, like how would I define, maybe looking at this collection of things, and maybe I need to modify the main template as well. And I need to remove this account really quick. And you might say, all right, well, how do I set up the proper name if I have 3 different things? And how do I know which web server to set up? And like, how does it know to use these names? And it can get very confusing because this resource is simply one resource item unless you add a count to it. But then if you do add a count to it, how do you choose what the different names are, what the server tag name is? What do you want to do? So actually, let's leave the count in there. Let's leave the count in there. I don't need to set this up like this because format will do it for me, but let's set it to 3. How you doing, Toto? Welcome to the channel. First off, we are doing some Terraform. We are finishing up a 6-part series called Hoist, Infrastructure Provisioning with Terraform. And so we're learning a few different things about Terraform tonight, a few key concepts. We just went over secrets management and understanding how to manage secrets. Right now, we are learning about the different functions that Terraform has in it. Terraform, it has its own configuration language. It's not something like Python or something that you're used to. a dynamic language that people might be used to. And so we're learning about the functions and tools it has in it to make us do some cool stuff. So let's look at some of the ways you can implement a loop in Terraform. It's interesting they brought us to this because we'll click preview. We don't need this. Let's look at a couple of these. And mostly I'm clicking into these because I never, like I said, I never memorized the syntax, and you probably shouldn't either, but it does have a few different options. It has so again, we talk about count, looping over resources. So count will work. Count is a loop, but it doesn't give you a lot of flexibility in the same way that something like for each is. Terraform's not a new programming language. Terraform is a infrastructure as code tool. So it's a tool that allows you to code a web infrastructure. So it allows you to code infrastructure in the way that it's configured, and it allows you to deploy that and use that to manage your infrastructure. So say we're using a cloud provider like Amazon Web Services, we can say, hey Amazon, we want 5 servers of this size that are connected to each other with this type of network, and we need this much storage, and we want to connect it to this, and you can define that via code and you can deploy it out. So yep, it's not a new programming language. It's just an important tool to help you manage web infrastructure. It's really kind of found its time to shine in the the big cloud boom and the way that we kind of manage infrastructure these days. For each loops allow you to loop over resources inline blocks within a resource, and I'll show you how that differs from the count and the for. And the last one is for, which allows you to iterate over lists and maps. So we just kind of created a list with the array that we just made. So yeah, and so actually let's look through this. Let's see what this person is talking about here. Count. So this is what a for loop looks like. This is not actually this Terraform. It's just kind of talking to you about how a for loop works, and maybe that'll help. For everyone who's not familiar with a for loop, let's hop over here and let's go over here and let's do let's vim for loop.python. All right, so we're hopping into a file right now, and we're simply going to say for actually let's do this in what I want to do. I don't want to implement things like range, but I'll show you. Actually, let's do it in Go, and I'll show you exactly what they were just showing in that example back there. We can kind of talk through it because I do think this is important to be aware of, so you understand how to use a for loop. I was actually really surprised, and I think this is why I've run across so many people who've written infrastructure and never used any of these tools. Because again, a lot of times people who are using Terraform are coming from the ops side of things and haven't really been introduced to concepts like this. Yes, when you're bash scripting and things, this stuff does come up, but a lot of the times, there are still a lot of people who've been exposed to systems in a different way and have never had to do anything like this. So let's I guess main. So we're writing Go right now, and we're gonna import. Go needs a little bit of boilerplate code to be able to run. It was just func. I never remember func main. All right, and so in here we're gonna write a little bit of a little for loop. We're gonna write a for loop to count to 100. So remember, a loop allows you to run a bit of code over and over again while a scenario you specify is true. And I'm gonna say for I is equal to 0, and I'll explain what these mean in a second. While I is less than or equal to 100. I plus. All right, and so what we just did is we actually set up the scenario. I know it looks confusing, Don't worry about the syntax. We're gonna go over the scenario in a little bit, and we're gonna do a format dot. Whoa, that just connects to. Okay, whatever. Format dot print line. I. Okay, so we just set up a scenario. So if you wanted to write a program that counted to 100, you would not want to write the line. So the way that you print something out to the console in this language, at least, is this line right here. And you wouldn't want to write this 100 times and insert a new number in here each time. That will take you a long time. That's dumb. Doesn't really make any sense. So we want to run this bit of code. Basically, we want to run that code 100 times, basically. And so what we do is we set up a scenario up here, and we say, hey, first thing we do is we're going to kind of set up a variable. So we're setting up a variable, we're setting up a counter for ourselves, and we're setting it up as I. You can make this whatever you want, and we're going to set it to 0. And here's where we're setting up the real scenario. Say, so as long as we're basically saying run this code for as long as I is less than or equal to 100. So as long as I is less than or equal to 100, please run this code. And so we see over here that I is actually 0. So we know it's less than 100. And this is what happens after the code is run every single time. So after this code block runs, every time it'll do an I++. This just simply adds 1 to I every time. So it'll run the first time when I is 0, it'll run. And then when it's done, it's going to add 1 to I. So I is now going to be 2. And it's going to check this again. It's going to say, hey, is 2 less than or equal to 100? And you're going to say, yep, 2 is in fact less than or equal to 100. Let me go ahead and run this code again. This code will run again. And then 1 more will get added. So I will now be 3 or whatever. You just keep moving up and up and up. And so if you run this, go run. Go, we can see here we get a printout from 0 all the way up to 100 without having to write the code that prints out a number more than 1 time. And so again, it's just going to loop over that code until it's no longer true. The reason why it stops at 100 is because, hey, when I is 100, let's say I is equal to 100, it says, hey, is I less than or equal to 100? Yes, it is. It is equal to 100. So this is true. So it goes ahead and it prints out the number. Then 1 gets added to it. So now I is 101. And again, this loop will only run as long as this scenario is true. And so what it will do in here is it will say, hey, is 101 less than or equal to 100? Nope, that's false. That is a false statement. So we are done running this loop and it won't run anymore. What's up, Mary Kona? Welcome to the channel. Thank you so much for the follow. Good to have you. So that is kind of how a loop works. And that's what he's kind of showing us here in the example that we kind of just found here. They're just kind of showing us an example of what that looks like. And you can see this looks very much like ours. But he did it in the form of Terraform. So he says, hey, as long as this loop is true, go ahead and create a resource for me. That is essentially what a loop does in Terraform. And again, he says up here, this is just pseudocode. This is not actually the way that you write it, but this is it's written in a way, because these for loops are something that are common to dynamic languages that people are used to. He's using that as an example to explain it as we just did. Okay, and so that for loop says, hey, as long as I is less than 3, go ahead and do it. And so it'll do it 3 times. And that is what count gets you. Count gets you this de facto for loop. So if I wanted to run a resource line 100 times, I can change this count to 100, and Terraform would pick that up and iterate through this block 100 times, even though we do not want it to do that. That is what it'll do. So let's take a look back. All right, so that's great. That works really well. And so they talk about one of the problems that happens is when you're running through something like that, you may need to change information between each run. And so we create a server with a bunch of information. Like, how do we change up the information that exists inside of it? How do we, maybe we don't want all of the resources to be the exact same thing. Maybe we need to, provide them different resources to connect to or something. And so you need to have a little bit of dynamicism in there. And so what it allows you to do, what we could do is we could actually use that I number that we were looking at. We could use this to talk about which instance that we're at, and we can make some changes based on that. And you can do the same thing using Terraform. Again, don't forget, Terraform is written in Go, so there's a lot of functionality that can be passed along because it is written using this language. Well, whatever it was written in, it could do that. But so here's an example here, and we can see what this looks like. But they have count 3, and then they're saying, hey, the name is actually going to be this this concatenated interpolated string of neo.count.index. So count has something on it called it has something on it called an index. So every time you're running through that loop, the index is the iteration that it's on, the number of times that it's run. So it starts at 0 and it moves on up from 0. And so if it's on the 3rd run, that number is actually 2 and not 3, but that is the index. That is the current run that it's on. So for this, the first time it runs, the count.index would be 0. The second time it will be 1. The last time it will be 2. And so this would name the servers Neo 0, Neo 1, and Neo 2. Well, not servers, but IAM users. And so you start to have a little bit of that dynamicness in here now. So rather than it doing things automatically and giving you the exact same information, it allows you to be dynamic there. But that's great. And so, but that's kind of the limits of the count function. So that the count function is a loop and allows you to do some stuff like that. The only thing that you have access to really is going to be the iteration of that index. But what if we need to do something better than that? Huh? What if we do something better than that? It allows you, because this index is a number, when you're looking at these collections or lists that we're talking about here, we have this collection of different server names that might be set up. Each of these server names is at an indexed value. So there are 3 items in here. There's web server alpha, web server beta, and web server Charlie. Now, because this thing is an array, what it means is that each of these items, the location of them matters. So their location inside of this list does in fact matter, and we can refer to their location using their indexed number. So these things are 0 indexed. So this is actually at the 0 spot. So web server alpha is actually at the 0 spot, web server beta is at the 1 spot, and web server Charlie is at the 2 spot. And so we can refer to these things using those index values. And so the example that they have here, shows them saying, hey, there is a variable set up just like we have a variable set up. This variable is for usernames, and it's a list of strings, and they have 3 strings in here. And so what they can do is the same kind of for loop using that count, but we can refer to the list index. And so where are they doing it at, or are they switching it up? We can do this. I'll tell you why it's not good to use it. Oh, okay, they are doing it. All right, so what they're gonna do is, instead of writing count, the count now is going to be a function of an amount. So let's say this thing right here, maybe, although this variable only has a list of 3 right now, that's the default value. And if there's a default value, that means that value can be overridden. So what happens if we say, this will work, if we were to set the count to 3, and then we were to create something, we were to say something like, it would be something more like this. I don't really remember the syntax, but it would be something like count.index. And so what would happen is, the first time it would run, it would, the first run would be 0. And when it got to this part down here, it would say, all right, let me check the server names variable at index 0 and insert that value. And so it would do that. And then the first time it runs and the second time it runs, it would do that. But what if we passed in 4 options? Or what if we only passed in 2 options, but we told it to count 3? It can get a little bit weird. So the ways that you can make this super dynamic is to use the length function. So we're talking about some functions that we have available to us. This is a common coding function. And so length allows you to determine how long a collection is. And so this could be different languages allow you to do different things depending on how they handle these different data types, but it allows you to see how long a collection is. So we can check the length of the variable. And so let me show you how that kind of works in something even like Python. So maybe we have something like Python, and maybe we have a collection. X equals 1, 2, 3, 4, 5. So there are 5 items in here, 5 separate items in here, separated by a comma. And now this is actually a list here. And if I do in Python, what is it? Len, I think it's len of X. If I check the length, it is 5. If I add one more thing to it, even if I add something different, even if I add the word hello, spell that wrong, and I hit enter and I check the length again, the length is now 6. I added one more item. It is checking how many items are in here. And so what we can do is dynamically check how many items are in a variable so that we know how many times to run this thing. And so what we can do is, for the count, instead we can use the length function that they're talking about here. And the length that we're going to want to check is we're going to check how many items are in that variable. So we're going to check the length of the variable usernames or whatever variable we want to check against. So we're going to check length var dot username. Oh, we'll call this server names. Var dot server names. All right, so we're gonna check var dot server names. And so no matter what this is, and I'll show you exactly, we're gonna pass in some extras and see how it changes, but it's gonna check server names, and the amount of items in here is how many times it's going to loop through this thing. And then let's make this a little bit more dynamic. So sure, we've got 3 things here. It's going to run 3 times. That's great. But how do we tell it to use, again, these different items here that are in the list? And the way that we do that is, again, okay, I almost had it. Call the variable, and we call the index with the square brackets instead of the curly braces. And let's do that. And so right up front, if we were to do a plan, if we do a Terraform plan, it should show us that we're going to have 3 different servers, all with the tag name of web server alpha, then web server beta, then web server Charlie. All right, and so let's see what happens here. We got a plan, module not installed. What do we change something? I should list strings. Is it list of string? See, this is why you should do a Terraform validate. And basically what happens is strings is not right. I think it's just string. The list of string, pretty sure that's it. No AWS provider. I don't know why that keeps happening. And let's validate again. All right, so we have another problem here. So an input variable with the name server names has not been declared, so we need to check that out as well. Looks like we just simply we were talking about the wrong, referencing the wrong name. It is server underscore names, and we just did server name. So we need to do server underscore names. All right, so you got to make sure you're doing the right thing. And let's validate one more time. And now our configuration is finally valid. And now what we can do is we can plan it out. And now that we can plan it out, take a look at what pops up. Okay, so first, there's a lot of them because there's 3 of them, and it looks like we already have some stuff deployed. But look at this, development server 0, which is the name that we have inside of Terraform to reference this. But if we scroll down and look at the tags, down here, where is it? Where is the tags? Tag name is web server alpha. The very first one here is in fact web server alpha. We scroll down a little bit. We looked at number 1, which must be replaced, no big deal. But this one is web server beta. And we scroll down a little bit more and we can see for this very last one that this will be web server Charlie, spelled it wrong, but web server Charlie. So you see how I can dynamically grab that information and choose based on what you have in that collection of data and apply it properly. And so you don't need to, like, to be very clear about this, you don't need to, if you want to spin up 3 web servers, you don't need to go in and do 3 different resource blocks. Now you can if you want, but if they're going to be the same, if they're going to be based off of the same thing, you don't need to have 3 different of these. Like I've seen this a lot, and you go in and check someone's Terraform code and they would simply have this. And this isn't wrong. This is not wrong. This is not wrong. If you were to do this and give them different names, not a big deal, having those 3 resource blocks. But again, there are cleaner ways to do it, and better ways that Terraform gives you the tools to be able to do this easily. And so it's also worth noting that, like, you can also do this with other things. So although we're checking the length of server names and we're using the index here, we can also we would also be able to use the count index elsewhere if we had other collections of data that we wanted to loop through. So maybe there was different keys. Maybe each of the servers had different keys, and we could loop through a collection of the keys as well. Now, let's set really quick server names. Let's set an environment variable really quick. Server names, and we had 3 in there the first time. Let's add in just 2 this time, and so let's do alpha, and I think B is Bravo and not Beta, but whatever. I'm not in the military. But now we just have 2 this time. Okay, wait, actually, how do I do that? There we go. And now if I do another plan, it should only show me 2. And the reason why it should only show me 2 is because the length of the variables that we're talking about are only 2. And so actually there's still 3 here. Hold on. Server alpha. Oh, do I also have these set up in, is it not server names? What is it? Dev instances. No, server names is what it's called. Do I have it set up in TFRs? No. Why is it taking the default and not what I set? Server names. That seems right. I wonder if it has to do, I wonder if I have to change the way that I do. Let's see real quick. I just want to check something out. Envars array. I wonder if I have to actually specify it as a thing. Ooh. Let's check that out. It might just be, no, I'll check that out. So that terminal, those terminal settings, I I'm not using Hyper anymore. I need to update that. I'm just using Vim, and I'm using Vim inside of what's this thing called? This thing is called Windows Terminal. This is Windows Terminal. This is Windows native terminal, and I'm using Vim inside of there. So you can check in like terminal settings. Terminal settings. You can grab my vimrc files and stuff. That's going to take you to the Hyper one, but in that same repo, there's going to be my vimrc stuff if you're interested in any of that. I wonder why that didn't take, actually. I wonder if I just didn't set this properly. Like, what if I just set it to like the gist alpha? And now I plan it again. Wonder why it's not overriding. It's taking the default for some reason over my mvars. My mvars should override the default, but all good. We're not gonna worry about that right now. What's more important, again, is simply that you can kind of see how these loops are being done, and that you can basically, this is going to run, it's going to allow you to iterate over these things. You can also use explicit for loops, and again, I don't want to write an explicit for loop here because I think that if you're anyone who's trying to wrap your head around loops right now, I think that'll even make you more confused. I think we've already used count before, and this paradigm might be a little bit easier, but you can iterate through many more things using for and for each inside of Terraform. And I'm sure, let's see what he goes through down here as he gets a little bit farther down. Loops of for each. I don't think I've ever actually used a for each. So this is where you can do it inline, like in the resource block. So rather than doing the count, you can do a for each of the collection, and you can set up all the keys inside if you need to. But this one is using the toSet function to kind of do some of that stuff. But there's a lot of information here. Let me actually share this in case you want to go through this. We're actually going to we are going to do some looping tomorrow or on Wednesday, but we're probably just going to use count. I'm probably not going to do a for each block. You have the choice. You can actually these are not all only good for certain instances. They are each better for certain instances, but you can kind of use some of them interchangeably depending on what you are trying to do. So maybe we'll try to show that when we get there. All right, so you check that out. The last piece of this is to talk about the actual the other functions though. So there is this thing called the Terraform console. A lot of people don't know about this. A lot of people don't use it either. I don't find it incredibly useful for the way that I do things, but I have seen people using more and more dynamic templates where this would be valuable. But Terraform console is an interpreter or HCL that allows you to test and execute Terraform functions. So internally to Terraform, there are a number of built-in functions that allow you to do cool things. Again, things like even count, even like allowing us to check the length of a variable are functions that are kind of built into the HCL. And so there are a number of these functions, and don't spend any time memorizing these at all, not even a little bit, because there are a lot of them. A lot of them are going to they're going to mirror things again that you've learned while you're learning how to program. But what it allows you to do is it allows you to do some really dynamic things when you are building out like really robust infrastructure, and to express these different things and do these transformations on values real time where you're trying to run things. And so a lot of cool things. There's some numeric functions, so you can do things like ceiling and floor. So these are mathematical functions which allow you to round up and round down. So closest whole number is greater than or equal to the number that's given, but you can test how these things are going to work and you can understand how these things are going to work using the Terraform console. And so if you have Terraform installed, you can simply type in Terraform actually let's go into this directory, make it larger, and you can simply type in Terraform console, and it drops you into an interpreter. So an interpreter just is a program that is going to read in the Terraform code that you provide, and it's going to interpret it for you and provide an output from that. It's going to interpret what it means, and it's going to output it. So there are things like seal the I before E, except after C. That makes sense. And so sealing of something like 5.2 is going to spit out 6. The sealing function allows us to round up, or floor, which allows you to round down. They give you some examples here, and these are all functions that you can kind of plug into here. But there's a lot of stuff. There's some mathematical ones, min and max. So if you give an array of numbers and you select max, it'll give you the largest one, which is nice. And let's do 167 and 7. I don't know. And it's going to make sure to give me back the largest of the numbers that are in this collection. Why would you want to use something like this? Again, you can use these for a number of things. You can use these to parse information or to make decisions based on informations that are coming through as variables. So if you're not sure if something's going to change, you can make some decisions based on that. You can make some decisions based on output variables as well. There's a lot of cool things you can do using some of these mathematical functions. And so there are a bunch. I would check them out. POW is exponents. So you can do some cool stuff with that. I actually don't know what signum is. Let's see. Determines the sign of a number, returning a number between -1 and 1 to represent the sign. What? Oh, so positive or negative or 0. Okay, that's sign. I guess it's signum, I guess. I'm not sure why you would use this, but again, it's there and it's available for you to use. So numeric functions, these are cool things you can do with numbers, so check that out. String functions are a little more useful. I've done many more things with string functions, and so these are going to be the cool things, like splitting up of a word. So maybe you have a URL coming in and you want to, that URL has data that you need. You can split that URL up based upon a separator. You can split that string up into different pieces so that you can do some cool stuff. So that's really nice. So I can say, hey, let's test out some things with this split function really quick. I can say, go ahead and split. Let's see what happens when you do an actual word. So in some languages, this will split it up into individual letters, and it doesn't. So it doesn't allow you to do that. So I have to tell it what to split on first. And so let me try if I do that. And that'll do it. So it splits it up into an array, which is a collection of letters here, with the first item being H, second being E, L, L, and O. Really nice. But maybe you want to split up a URL. Maybe the URL is academy.mastermind.io, and maybe you want to split it on the dots. And so you can split it on the dots, and maybe you want to split it on the dots and you want to take I mean, this is not going to work, but I'm just going to try to type this in. Maybe you want to take this the second item, which is mastermind. It did work. I can't believe that actually worked. Actually, yes, I can. But so it splits it up in different pieces, and then I pick the index. So this is the 0 index item, the first index item, the second index item. So number 2 defines mastermind right there. And so being able to split this up and then defining an index allows me to pull out information that I want. And so again, this is how you can use this to dynamically find out information. Maybe you have an output variable that has some stuff in there. Maybe you're doing some I don't know, some subnets. Maybe you have like you know, you're using a certain subnet and you know that the first 3 octets are going to be the same, 172.108.678. Maybe you know all that's going to be the same, but what you really want to know is the last 3 because you just spun up a new server and it might be something like this. And what you can do is, what's the 0, 1, 2, and then this will be 3. So maybe you just want to know those last 3 octets, and you can get out like that. Maybe you're grabbing that from an output variable. Who knows what you might want to use it for, but you can use it to grab some cool things. So that's really nice. Lots of stuff here. There's like uppercase and lowercase. Can't run away from arrays. Never. You can never run away from arrays. They are used everywhere for everything. And so the faster you can get the concept down of how arrays work, you know, the better your life will be. Make it much simpler for you to get stuff done. But yeah, there's just all kinds of stuff. You can substitute values. You can do some string substitutions, and so you can, you know, you can strip out certain things and put in certain things if you want, and take substrings. You can uppercase things, and there's all kinds of different string functions you can do. So these are what you can do to your letters, your different characters. Collection functions, these are very interesting, and while I do more string functions than anything, I think that there's probably been the most cases for me to do these collection functions more than anything, and these basically will perform actions against collections, against those arrays that the AI just so conveniently told us that we can't get away from. We can't run away from these things. And so what is this? Coalesce list. I don't know what this is, but takes any number of list arguments and returns the first one that isn't empty. Okay, so maybe if you're, you know, maybe if you want to make sure, maybe if you're expecting some empty values to come through or something, coalesce list, you pass in your values. So they're passing in 2 arrays, 2 collections, and this one is not empty, so it returns that one because it's the first non-empty one. This one, the first one is empty and the second one is not, so it returns the second one. Interesting. I have no idea why you would want to use this. I have 0 idea on why you want to use to perform the coalesce list operation. Yeah, I don't know. I don't understand why you want to do this, but I understand why you would want to use this, which is coalesce. Coalesce takes any number of arguments and returns the first one that isn't null or an empty string. This is very nice when you're passing in, you know, these singular things rather than those big collections. I'm not really sure why you would want to do it with collections, but this will be good to check. You can use this to remove no values and things that might mess up your code, which is interesting. But we've already used length. So length is something that we use to determine how long a collection was or an item was, which is great. And so the way that we use length in here was pretty, well, you just call the name of the function and you pass in what it wants. That's the same way you use all of the other things. I could, you know, if I wanted to use coalesce somewhere, I would instead do, I have no idea how to spell I have no idea how to spell it. No idea. It's hard to read, hard to say. Coalesce. That's what it is. It's coalesce. I think I've seen coalesce used with. Yeah, I can definitely see coalesce being used. I've never used it, but I for sure can see that being used. I don't understand the coalesce list though. Like, I understand it, but I don't understand what I would use it for. I'm really trying to think through, but I could definitely see coalesce being used in a number of places for checking for no values. I called it coalesce, and so it would, and then I would pass in whatever I need to pass in. So that's how you would use the functions, and just pass in the information. But again, we don't actually want to do that right now. And so again, there are a number of these as well. It's good to become familiar with them, but I just don't think you're going to remember all the functions that it has available to it. Like I refer to this whenever I want to do something that I don't know how to do. If I want to see if it's something I can do, I'll end up here looking through these functions to see if I can get it to work. But there are a bunch of them. There are a bunch of them for encoding, which is really nice. There's a bunch of stuff. Also be careful with I've seen people try to do some base 64 decodes and stuff for secrets. It doesn't make any sense. It looks like you've encrypted it, but you have not encrypted it. But like that's not a hash. Like it's not a special hash. You just converted it to a different format. Yes, it looks like you've obscured it, but it's not. It's very interesting. I've seen people do it before, but I've also come across articles of people advising you do it for some things. I'm like, no, maybe not basics. Well, yes, I've seen it. It's weird. Don't do it. But yeah, lots of functions. Check them out. Know where they are. Know that you can just Google Terraform functions and get a list of the functions that you have available to you. And again, these are the things that make you good. If you already know your platform, let's say if you want to be someone who's using Terraform to work on GCP, and you know GCP really well already, like you understand Google Cloud Platform, you know how it works. Now you're learning Terraform so that you can manage it. It's gonna be pretty quick and easy for you to get up to be able to spin up resources and manage resources. There's only a couple of different kind of code blocks you can do. Again, there's that resource code block. You set up your provider. You set up your credentials and you set up some resources blocks, and you can do that. That can get you kind of far. But when you really get good and when you really start to understand these things is when you start learning how to use these functions and use the tools Terraform has to make your code. Again, it can make your code base substantially smaller. It can make your code base substantially smaller. It can make your runs faster, actually. And it can make the management of it much easier. And you can get to do some really tough things when you have some interesting infrastructure that sprawls and has a lot of different pieces. Using these different things can really help you do all of that. And so, like I said, the Terraform console will help you with that. If you ever want to just test out a function to see how it works, feel free, hop in there and everything will be good to go. Oh, but that's that. I'm sorry. I don't know why I keep I don't know why I keep yawning. I need some coffee or something. All right, and lastly, this part might take us a little bit, but importing infrastructure is the last piece we're going to talk about tonight. It sounds cooler than it is. The first time I heard that you could import infrastructure in Terraform, I was like, this is great. Why would I even need to ever write Terraform when I could simply spin up the infrastructure as I know how to do already, and then I could import it all and life would be good. That is not the case at all. It is actually, I found this to be much more of a hassle than it's worth. I think the easier thing to do here, if possible, is to start over and write it all new. But sometimes, that's not always the case. You can't always do that. Sometimes things already exist. While you're normally going to be provisioning brand new infrastructure with Terraform, sometimes you'll need to handle some old stuff. And again, it's actually a very important, it's actually a very beneficial tool. But again, it's annoying. It's very annoying, and it's not something you'll be doing often, guaranteed. So the way that you do this is simply by importing it, and you can import it in existing infrastructure. Some of the caveats that you need to know about this is you can only do a single resource at a time. That is key right there. You cannot import, an entire VPC and all the subnets and all that stuff together. You have to import a single resource at a time. Okay, you want to say, all right, well, that's okay. I can do one resource at a time, but it does not import the configuration of the resource. So it ends up changing the entire workflow for Terraform. So what's the normal workflow for Terraform? The normal workflow is to write your configuration. After you write your configuration, you plan it out. And after you plan it out, you apply it. That is the normal base workflow of Terraform. Import works much differently. And so what you do is you import first. And after you import your resources, you then have to apply. Then you have to write. So you have to import first. Then you have to write the configuration, because that configuration does not get imported. And then you can follow the same path, and you can plan and you can apply. But it's really interesting. And so there is a really good HashiCorp tutorial on this that does it locally with Docker, and we're gonna run through this. And the reason we're gonna run through this is because it won't take that long. But this is not a fun process. I don't think doing imports are fun. It can be kind of annoying to do to get it to work like the way that you want it to work. You've got to, after you import the stuff, you got to figure out exactly the things that you have to configure. You got to go get that information. Yeah, it's interesting. And so again, this is the normal workflow: write your config, plan, and apply. But now you got to import the existing infrastructure, then write, plan, and apply. So the end stays the same, but you're writing now to, instead of writing to something that you want to exist, you're trying to figure out how to write to something that already exists. And it kind of sucks, to be honest. But let's try to run through this. I've never run through this, but usually their stuff is good. And the example that I had was probably more confusing than it's worth. And so let's try this out. So prerequisites: you need Terraform CLI, Docker. So I already have Docker installed. If you ever want to run through this, you gotta have Docker installed, and Git. I'm not sure what you need to Git for this, but we'll find out. So they're gonna want us to use the Docker. And so basically what we're gonna do is, it seems like we're gonna have a Docker container that is running, that we deployed manually. We did not deploy this infrastructure using Terraform. We just deployed a Docker container on our own. And I guess we're gonna import that into Terraform. Now, I want you to think about what importing really means. If it's not pulling in the code, like if it's not pulling in the configuration and like setting up that code for you, what is it actually importing? And the thing that it's doing is really importing it into the state of your machine. It's really importing that information into the state. That's what you're trying to do. You're trying to take the current state. You're trying to take the current state of whatever that existing resource is, and you're trying to get it pulled into the state of the rest of your infrastructure that you have. Ooh, okay. So create a container named HashiCorp Learn using the latest Nginx image. And so I'm just gonna copy and paste from them. And so if you haven't followed Contained and you don't understand Docker, check out YouTube. Those 6 episodes are up there. I need to throw up Waddle as well, but you can find out what's happening here. But we're gonna spin up some Docker infrastructure really quick right now. So let's do it over here. Let's see what I have running already. Also, what's up? Fold Pipe, PA Fole Pipe, or is it Path Old Pipe, or is it P Affle Pipe? Welcome to the channel. Good to have you. Also, what's up, Snitary? Welcome. What's up, Blackout 2830? Good to have you. So let's see here. Let's clear this out. A CD. Let's Docker PS. So Docker is a container tool. I have 1 container running. Don't worry about that. I'll stop it, but it's gonna start right back up, to be honest, but I'll stop it anyway. What? There's only 1 running though. They're playing me. We'll stop it so that there are none, but I do think it's going to start back up. I'm pretty sure that has a restart always. Cool. So what we're going to do is run the command that they gave us here. That's not it. We need to go back and copy it. And this is going to run an Nginx container for us. Nginx is a web server. and it's going to run it locally on our computer. And if I do a docker ps, this is it. It's running right now, and it's exposed on port 8080. And so if I curl localhost 8080, I get an Nginx page. If I go to localhost 8080, I do in fact get a welcome to Nginx page. So web server is simply an application that serves data over the web, serves content over the web. It's exactly what it sounds like. And so when I make a request in my browser, I'm getting this, and this is being served right from my computer, right from right here. And so great, we have that running. But again, this is not infrastructure that we deployed using Terraform. And so I guess it's gonna walk us through pulling that configuration into our setup. So let's take a look. All right, so verify that it's running. We did that. Visit the address. We did that. So import the container into Terraform. This is the first part. Okay, they want us to clone a repo really quick. No problem. So this is an example repository they have for us. Great. It's called Learn Terraform Import. So in here, let's see what's in here. Let's see what's in this directory. There's a README, which tells us what to do. Learn what Terraform import is and how to use it. And this is where you can follow along. Install the prerequisites, create a Docker container. We did that. Verify it's running. We did that. Now import the container resource. So that's okay. So there's a README that basically has everything that's on the website. Then we have a main.tf. All this has in here is a provider. And again, what is a provider? A provider is those sets of tools and things that allow Terraform to talk to the APIs of whatever the service you're trying to use is. And so the provider, we've been using AWS. The provider they have here is Docker. And this is the only thing in this main Terraform file. But if we check up here, we have this docker.tf, which has a couple things in it. So take a look at it. It has a resource, which is a Docker image. It's got a Docker container as well. But I think this is where, this is the final configuration. So I guess this is where we're gonna end up with. So let's just follow through with what, I guess we're gonna take this file and end up with that file when we're done, I guess. I don't know. So let's take a look. Let's now do what it says. So first thing they want you to do is the first piece of the pie, which is Terraform init. So we're familiar with that. So let's go ahead and run our Terraform init. This is going to get all of our provider information as well as any modules we might be using. Terraform init. All right, successfully initialized the backend, all that other stuff. So great, that looks good. It says next, define an empty Docker container resource in your docker.tf file, which represents a Docker container with the Terraform resource ID docker container.web. What's up, Managed Chaos? How are you doing tonight? We're just knocking out some of this Terraform, man. Right now we're learning about importing existing infrastructure. We're running through HashiCorp's learn of it, just because I think it's a good walkthrough, and it's going to be good for us to talk through what's kind of happening here. And it looks like they're doing it with Docker, which is kind of cool. I've never done anything with Docker with Terraform, so this is nice. And so what we need to do is in that file, we're going to set up a resource. So the first thing you have to do when you want to import a resource, you need to set up a space for that resource first. It won't work if you don't first set up just an empty space for it. So notice how it has an open and closed curly brace. So yeah, you need that little open and close there, a little empty space to collect that resource. So let's put it in there. They said put it in the docker.tf file. Notice the docker.tf file. This is all empty. Why'd they give us the final? I'm gonna delete all this. No, I'm not. Here's what I'm gonna do. I'm going to move docker.tf to docker.tf.back, and I'm gonna vim docker.tf. And he said, hey, just go ahead and put a resource in here. So Docker container web. And so set up web space for it in It's going to be a Docker container. That's the type of thing the resource is. We're going to call it web. So Terraform is going to know it as web, and it's empty. And so if this helps, this might help for you. This block might make it a little bit better for you. But that's the exact same thing. And so we set up an empty space right there for us. And so after we do that, it says, all right, run a Docker PS to find the name of the container you want to import. In this case, the container you created in the previous step. So the container that we created in the previous step, the name of that container is HashiCorp Learn. This is the name of the name of the container. If we didn't provide one, it would have been given a random name. And so you need to find the identifier of the resource. If we were importing something in Amazon, we would have to find something like the Amazon resource name to be able to import this thing. So there's going to be a unique identifier to that thing that you want to import into your Terraform code. And so it says grab that name. What does it say do with it? It says now run a Terraform import to attach the existing Docker container to the Docker container web resource you just created. So we're basically we created this empty resource that's in here. We created an empty resource. Now we're going to connect the running container and connect it basically to this resource right here. And so the way you do that is with that Terraform import, and there was more to that command. And so Terraform import, and I have to tell it what the Terraform resource is. So Docker container.web is the thing that I want to connect it to. And so we'll copy that really quick. We'll break down the rest of all of this. All right, and so this is where I find that tutorials sometimes do people a disservice. They explain what they're doing here, which is very good, but they do people a disservice. It makes it look very confusing. But they have this extra stuff here that makes you think that you've got to do something very codey to get this out of here. And you're like, well, what is this? Docker inspect -f and curly braces .id. The next thing that you have to do, really all you're doing is saying Terraform import, and you're basically saying, hey, I want you to import into this thing. So into Docker container.web, I want you to import this thing into this thing. And what this thing is really just the ID of this Docker container. This is an easy way for us to get it. It's an easy way for you to get it. It's actually good in tutorials because it allows people to copy and paste easier, but I think it's harder for people to understand who may not be super familiar with what you're doing. But it's just grabbing the container ID. And so what I can do is, instead of doing that, I can actually grab the container ID. And so I can do that by doing a Docker inspect and inspecting the HashiCorp Learn container. And that's basically what this command is doing. And I can scroll up and I can grab, this ID. So basically what's happening is that command is basically pulling out this information right here. And so we can take that instead. But if I do this is the exact same command. What's here and what they would have had us copy and paste, it's the exact same thing. And when I do it, check this out. It says importing from this ID. It's import, the import is prepared, it's imported, import successful. The resources that were imported are shown above. These resources are now in your Terraform state and will henceforth be managed by Terraform. So we've done it. So we've got it into the state. And that's really what the import is doing. Like, all it's doing is figuring out how to add the currently running thing into your state. Now, we aren't done. It looks nice and easy, but we simply are not done yet. Why aren't we done? Check this out. If I were to do like a Terraform plan, it gets confused. And why does it get confused? It's because I have this thing now loaded into state with some information, but my configuration does not yet reflect what is in the state, and we've kind of got to get those things matching up. So this is where your work comes in, and now you have to go in and put the, fill in the missing information to make sure your configuration matches what is now in the state. And so that part can be pretty annoying. Let's see. And so I can see my state by running Terraform show, truncated things, but let's run that. It works. Let me pipe it to JQ. Oh, is this not invalid numerical literal? Interesting. Oh, okay. It's never mind. It's not JSON. It is, but kinda. It's HCL. But in this state, if I do Terraform show, it's showing the state here, and this is the state. This is what it's seeing, the resource container web, and it's showing what command it was started with, and all of the information, the gateway, host name, ID, image ID, IP address. It's showing all this stuff is available in Terraform state. The ports that are exposed, it was able to pull that into the state, but again, not able to define that in the configuration. So now we got to create that configuration. We got to go ahead and write it now. So if we did a Terraform plan like we did, it'll show us the things that we are missing, and once we see the things that we're missing, we can go ahead and we can build that out. So there are two approaches to updating the configuration. You can either accept the entire current state or cherry pick the required attributes. You could take all of the stuff that was popped out by the state. I could take all of this and paste it in. This is a resource block right here. This is a full resource block. Hey, Callow, how are you doing tonight? Shout out to Callow. Every time. Hope you're doing good, man. We're just finishing up some Terraform stuff, but this is an entire configuration. You could take this. You don't want to take this. Like, you just don't want to. You don't want to take this. You don't want all this in your Terraform code. Take the things that are important. That's what you should do. So you can start with that if you want and pare it down. But yes, cherry pick information, and so I can go in and I can get the information that it says we need. So it says we need things like we need name, and we need things like image as well. We can find out what those exact values are right here. So name, HashiCorp learn. I can literally take this and image. I can literally take this image right here if I'd like. It's interesting that they put it through in a SHA, but that's fine. We can do that. I'm good. I'm good. I'm a little tired. I just got tired though, but I'm good. I just saw you think, yes. It probably was the bike ride probably hurt a little bit. All the weekend bike rides. You know, I'm back in. I'm really trying to stay focused, and so I've been pretty consistent in the gym and stuff too. But I don't think that's it. I think I had more sugar today than I usually have because we got some Capri Suns for this or I forgot what we got them. We got some Capri Suns, and you know, taken back to my youth, I gotta drink the Capri Suns. They're in the fridge. They must get drank. They are, you know, they're great. Look at this. Look at this. Look at this little pouch of happiness is what I call them. Strawberry kiwi is not the ideal flavor, you know. Pacific Cooler is in fact the ideal flavor, but you beggars can't be choosers. A little bit of nostalgia is always a good thing. Managed Chaos, thank you so much for the 7-month the 7-month subs, the 1-month streak. Appreciate the prime sub. Good to have you. You've always been supportive, man. I appreciate it. I hope we can get out to you know, hope one day BitCon comes back. Maybe we gotta throw some maybe we gotta throw a fancy remote BitCon or something. You remember when it came out? Okay, yeah, I don't remember when it came out. I do remember when Kool-Aid Jammers came out, and I was like mad because Capri Suns was my thing, was my jam, and I was like, yo, Kool-Aid Jammers, you're trying to steal the sunshine, you're trying to steal the spotlight from Capri Sun. Like, you gotta get out of here. Same way I felt about Digimon. I was a Pokemon fan, and then Digimon came out. I was like, Digimon, you're stepping on the toes of the greatest. You gotta back off. I need y'all to step to the side. This is Pokemon's time. Forever will be Pokemon's time, you know. But you know, all good. Definitely to make it visual though. can't pop to JQ, but simply like now that we have this in here, I can simply add these things. So let's actually vim that up real quick so we can be done, because we have 6 minutes. The docker.tf, Pokemon is the boss. I 100%. For anyone who did not see, I do believe that Pokemon is the original DevOps workflow, and I stand by it. I will send you a link to where I said it, and I'm the authority on that. I said it first, and I stand by it 100%. You know, don't at me. It's true. Pokemon taught us the original DevOps workflow, and one day I'll tell you why. Not today though. So name equals HashiCorp learn. And what was the last thing? The last thing was image that it needed, and it was that SHA. Oh yeah, I mean, I think they posted it somewhere. I'll see if I can find it. But everything I said it and I believed it. Someone thought I was like, oh, like I like that you made this this talk, like, you know, it's cool that you were able to find those connections, but like, I don't know, they didn't feel like I believed it, and I was like, no. These weren't connections. This was life. Pokemon was life for me, and everything I was speaking to you about Pokemon and DevOps was it's life. This stuff is true. I believe this stuff. They were like, I don't believe you. And I was like, well, hey, you know, you should believe me, because I mean it. Why is this in the? Why would it import the SHA? I guess that's what comes out of Docker inspect. That makes sense, but like, it just seems weird. All right, so now we have a SHA and an image. I think those are 2 things that it said we needed. So if we do a Terraform plan, look at that. It's going to, it allows us to actually plan it out now. But what it will do is, because we didn't specify all the other things that matter, it's going to kick out some of those things. It's going to remove some of those things. It's going to change some of those things like the port mappings. There's some specific port mappings in here that are specified that we do not have. And I guess that's how you get from, if we follow this through, which I'm not going to do, it'll show us how to get from where we were to where it wants us to be, which is inside of this tf.back file that we have. And so, you know, they imported a name right here. They imported an image, and basically they just added some ports in, so as well. So we could kind of steal that if we wanted to as well. But that's the workflow for importing infrastructure. It is to, one, set up a remember, you can only import one resource at a time. Set up a space for that resource, so set up an empty resource block. Import that resource, import it by importing it into whatever name you give to it, and specifying whatever identifiable name that the resource has. So again, if it's Amazon, it might have an ARN, an Amazon resource name that you might want to refer to. To say, hey, go ahead and import this thing into this Terraform resource. And what that will do is that importing will take the current running setup for that thing and import it into your state, into your application state. And so that's great. It gets it into the state. But once you get it imported into state, now you gotta modify your configuration to act accordingly. And then you have 2 options for that. One is to take the entire section of state. Remember, the way that you can see what that state looks like is to do Terraform show, and you can see the full resource block of that entire thing. So with every single option set, you can copy and you can paste that into your stuff, and that will work. And I don't think that hurts. I think you can take that and then you can start deleting stuff. So all the stuff that's empty, you can go ahead and delete all those things, start there, and then maybe you just delete some other things that you're not worried about configuring, and you can pare down to what you want it to be. Or you can do the opposite and just take the things that matter. Again, I say only import if you must import. If if you can, I say start from scratch and migrate your application or infrastructure over to whatever that newly created thing with Terraform is. But that is it, right on the dot. So what did we learn tonight? Tonight's tangible takeaways for tonight are: one, that secrets management is a thing in Terraform. Secrets are sensitive information that you need to configure and properly set up infrastructure in Terraform. Things like passwords, things like usernames, things like API keys that you don't want to store. So one of the no-nos was do not store any of these secrets in plain text. You don't want people to be able to get them, and do not put them in version control in plain text. That's the biggest key. You don't want to track those things. You don't want to push those things up, because then people can steal your information. But we learned that some of the ways that you can manage these secrets are: one, by environment variables, which is kind of your lowest barrier to entry, using those TF_var_ a variable name things that you can use. Then we learned that you could actually use encrypted files or encrypted secrets, and there's a number of options for that, but you can encrypt either a file or encrypt an individual secret with using some type of encryption tool like KMS or PGP, and you can actually set up Terraform that when it runs, it can decrypt that information and properly store it or properly input it. What's good about that is the differences between the first one, the environment variables, and that one is environment variables. You are not managing any of those secrets inside of Terraform, so it kind of separates where you're managing that, and that can be, problematic. Encrypting those secrets now brings it into Terraform, which is nice, but you do have to do the management of keys and things, and also you don't get any type of automatic rotation or anything like that, and that's where your the last thing comes in. The secrets management tools come in, again, things like HashiCorp Vault or AWS's secrets manager allow you to manage these secrets and to pull these secrets at runtime as well, and allow you to do some automatic management of those secrets, things like rotation and stuff like that, expiration, all kinds of stuff like that, which is kind of nice, but that's going to be the most expensive. There's going to be more overhead there and figuring out what to do, so you have to choose accordingly, but you do have a few options for managing your secrets. We also learned a little bit about the functions that exist inside of Terraform. We learned that there are built-in functions, a bunch of them, a lot of string functions, a lot of numeric functions, all kinds of stuff you can do, collection functions, just as you could do if you were programming. We learned the length function, so you can check the length of a variable to determine, how many times you want to loop through a resource block. We learned that there are 4 loops inside of Terraform that allow you to, again, loop through different pieces of code or resource blocks to be able to perform many actions with a singular block of code or block of configuration, which is nice. And lastly, we learned about importing infrastructure. We learned that you can, in fact, import existing infrastructure if you need to. If infrastructure already exists, you can first create an empty resource for it, then import that thing, and then you must now write the configuration to kind of match up with what you imported. You can get the whole configuration by doing show Terraform show to see the state. You can grab that resource basically out of the state, or you can do a partial configuration where you add in only the things that you need, but you must do that after you import it, or else it will not work and you'll never be able to deploy it or anything like that. So you basically learned all of the main things that there are to know. The only thing you haven't learned yet really that's meaningful is workspaces. It's the first thing we'll talk about on Wednesday, but on Wednesday we'll be doing a lab the entire time, and so we're going to be building up some pretty cool stuff. We're going to be basically reading through tickets. We're going to be reading through user stories to be able to build out some infrastructure. We're going to move quickly through it because we don't have that much time, but we're gonna move pretty quickly. But we're gonna be trying to solve a number of different problems that are gonna be introduced to you as they would be introduced to you kind of in the workspace. Yes, yeah, like I said, if you can avoid imports, please avoid imports. Not please, but like I just think it's easier and cleaner to set it up, do it from scratch in Terraform and migrate things over if you need to. But again, that's not always the case. It's not always an option, so you do have it available to you. I want you to know that you have it available. That's it. We'll be back tomorrow with build. So last week on build, we spent some time architecting out what we were going to be moving forward with and how we're going to be moving forward with this project. We'll do a little bit more of that tomorrow, as well as starting the actual build out. Now that we've chosen the technologies to kind of know where we're going, but we'll kind of start the actual build out tomorrow, and we'll be writing some code, having some fun. It'll be pretty chill. Come if you got any questions or anything, come on through. And then we'll be back again on Wednesday to finish this out. Information will probably be dropping tomorrow about the remainder, about tomorrow and Wednesday. I think I have it scheduled, which will give you all the information about what's happening between now and September 18th. Again, September 18th is that ultimate day where I leave the corporate world. And so we're gonna be filling out that time with build and a few other things. We have Git coming up, so the Git workshop is actually only going to be a three-parter. It's either a three-parter or a four-parter, so not as long as some of the other things, but a few other technologies coming up, if anyone is interested in that. And some announcements will be coming out. I think I have a schedule for next week about all the next journeys. All the journey information. We're doing it. I'm just letting you guys know right now, we're doing it really big for the journeys. We have to do it big for the journeys because, again, I'll be full-time, and I'll have the time to commit to it, but we're doing it really, really big. It's gonna be a much different experience coming through. We've been not just me, I've been working with some people planning out how to make this work. I've been learning a lot about Twitch and Twitch's integrations and all the different crap you can do. But it'll be much more of a production, so keep an eye out. It's gonna be interesting. It's gonna be fun. Also, just to see where we can take this thing. But it's gonna be fun. Oh yes, it's September 19th, the Mastermind Century Ride. I am. You know what? I've got a big battery bank that I'll just tuck into my bike bag thing. I have a frame bag, a top tube bag, and I can just tuck that in. Yeah, I'll just live stream the whole thing. How about that? I love it. I'm gonna try it. I'm gonna test it out. I'm gonna try it out. But cool. Who are we gonna head over and raid this evening? Let's see who's online. Not the chickens. Our chicken life, even though that I spend a lot of time on my chicken life, to be honest with you all. More time than I should. I feed those chickens often. Mr. Griffing's on. Melky Dev's on. J.W's on. Let's make a new friend tonight. Let's see. Let's play through. Oh, this is perfect. This person's doing Pulumi. We have to head over to this one because Pulumi, we're doing Terraform. We talked about other infrastructure provisioners, which is Pulumi. Pulumi is one of them, which is pretty dope, and it just makes a lot of sense for us to head that way. So code with Sean, I like that. This right on brand. So let's raid. Code was it with Sean? But appreciate everybody. I'm gonna go get some rest. I have more work to do, but I'm gonna get some rest. See you all tomorrow for build. Come on through as we build. Help me build. Open source project. You can contribute. We can have a lot of fun. But let's go say hello to Sean and see and make him argue with us on why Pulumi is better or not better than Terraform. Peace out, everyone. I did it too early again. I forgot I have a 10-second countdown, but peace out, everyone. You're gonna have to look at me for another 6, 5, 4, 3, 2, 1. Peace out. Have a good evening.